In this video, we're going to discuss integration resulting to inverse trigonometric functions. So here are the formulas that we need to memorize, or at least familiarize. If the given integral takes this form, so number one, we have here integral of du divided by square root of a squared minus u squared. Same with other formulas class. U here is it's a placeholder for any function or any expression. So in this case, it's any differentiable function, let's say in terms of x or in terms of y or any other variable. Okay, and then a here, a is any constant. Okay, so again, if the given integral takes this form, then this is integrable, or its antiderivative is arc sine u divided by a plus c. Okay, then next, if ganito naman na form, du divided by a squared plus u squared, or ito interchangeable kasi addition naman, commutative property ba. So it can be written as u squared plus a squared, either way parehas lang. Then this is integrable, or its antiderivative is 1 over a arctangent u divided by a plus c. Okay, then lastly, we have du divided by u times the square root of u squared minus a squared. Okay, so you might be wondering, we have three formulas, when in fact, going back to differentiation rules, we have 6 differentiation formulas or differentiation rules corresponding to 6 inverse trigonometric functions. Tama ba? However, we also have to remember that, for instance, let's take arc cosine. If we differentiate arc cosine, its derivative is just negative the derivative of arc sine. Kumbaga, the general form of the derivative is yung derivative ng arc sine. Okay? Pag arc cosine is negative lang nung arc sine. Tama ba? Same with arc cotangent or inverse ng cotangent. Its derivative is negative the derivative ng arctangent, and of course same with arc cosecant. Its derivative is negative the derivative of arcsecant. Okay, kumbaga there are three general formulas, differentiation formulas: arc sine, arctangent, and arcsecant. Therefore, if we take its reverse operation, itong indefinite integration, we can summarize the antiderivatives into 3 formulas lang. Okay, katong mga general formulas lang ba. So arc sine, arctangent, and arcsecant. Okay? And then sige, let's recall arc sine, derivative ng arc sine. Let's say derivative with respect to x, arc sine of x. This will give us what? 1 divided by 1 minus x squared. Okay. So actually, the argument here of arc sine, which is x in this case, is actually x over 1. Tama ba? And 1 here corresponds to 1 here in the radicand in the formula of arc sine. And x also here actually is x divided by 1. Okay? And it can be any constant. So here in indefinite integration, we can account for all constants by using a, okay, to represent all or any other constant. Okay, that's why we have here a for the antiderivatives. Okay, the integral and the form of the integral that we have to satisfy in its corresponding antiderivative, so as to account for any other constants. Okay, so let's look at some examples. So number 1, we have here a simple example, straightforward application of the formulas. So here we have integral of dx divided by square root of 16 minus x squared. So this involves a radical. So this leaves us with arc sine or arcsecant to consider. Kasi wala namang radical sa arctangent. So most likely, this is integrable either using arc sine or arcsecant. Pero definitely not arcsecant kasi wala namang extra na variable term outside the radical. And the radicand takes the form constant minus variable term. Diba? Nauna ang constant. I mean, positive ang constant, negative ang variable term. Talking about arc sine na formula. So, balik tayo sa formula. Ayan. So, again, A is constant. So, pag arc sine, this involves an expression na constant term minus variable term. Okay? And if you look at these expressions, itong a squared minus u squared, a squared plus u squared, and u squared minus a squared, all of them are quadratic expressions. Na to be specific, incomplete na quadratic expression. Diba? Pag quadratic na expression, complete na quadratic expression, it's a trinomial. We have the quadratic term, we have the linear term, and the constant term. Okay, pero in this case, we only have the quadratic term, u squared, and the constant term, itong a squared. So, we have to be mindful of the expressions involved in the given integral. Kasi there are cases where ang given expression is not directly written in terms of a squared minus u squared or a squared plus u squared or u squared minus a squared. Kumbaga, not directly written in terms of quadratic na form, kumbaga. However, there are cases also na we can manipulate those expressions, kumbaga, siguro given, for example, mga higher degree expressions or higher degree polynomials. There are cases kasi na they can be expressed so as to take the form of a quadratic expression. Okay? And if that's the case, then baka we can apply integration resulting to inverse trigonometric function. Okay? So it involves algebraic manipulation, like for example, completing the square or factoring, so on and so forth. Okay? So we'll see later on those types of problems or those types of integrands. Okay, let's go back to number 1. So again, we have here constant term minus variable term, and both of the terms, both of them are perfect squares. Okay, so walang problema. 16 can be written as square of 4 or 4 squared. Because of course, x squared is x squared. Okay. So let's identify the components of the formula. So a here is 4, and then u is x. If u is x, then du is dx. Okay. So this expression now takes the form, if we replace everything in terms of u and a, then dx is du, and then integral of 4 squared, 4 is a, so a squared minus x squared, x is u, so u squared. Alright, so this now is integrable using the arc sine na antiderivative. Okay, so this is now our final answer. Next, we have here integral of dx divided by 9x squared plus 2. So no radical this time. This leaves us with arctangent. Okay. So here we can write 9x squared. 9 is perfect square. X is of course perfect square. So we can write 9x squared as square of 3x. Tama ba? And 2, although 2 is not a perfect square, we can convert 2 into an expression where we can extract we can extract an exponent of 2 so as to write it as a squared, kumbaga. Okay? So, yan. So, a is square root of 2 kasi square ng square root of 2 is just 2, di ba? And then, u in this case is 3x. So, du is 3dx. Okay? So, in order to satisfy arctangent, or in order for this to be integrable using the arctangent formula, we have to have du in the numerator, and du should be 3dx. However, in this particular example, we only have dx in the numerator. So, we have to multiply 3. And since we multiplied 3, we have to divide by 3. That's why we have here 1 over 3 as the neutralizing factor. Or, if you're not comfortable with this type of method of applying u sub or carrying out the integration, then we can replace everything in terms of u and in terms of a so that we can clearly see na it is integrable using, in this case, arctangent. Okay? So, if we explicitly express the original integral in terms of u and a, then, so initially we have dx in the numerator. If we express this in terms of u, then we have to we have to convert this to du, okay, using this equation. So dx from here is du over 3, or 1/3 du, right? Okay. So if we plug in du over 3, we can just simply factor out 1/3, right? Then du in the numerator. Okay. Then square root of, wala palang square root. Divided by 3x squared, where 3x is u. So that would be u squared, right? Plus square root of 2 squared, where square root of 2 is a. So a squared. Okay. So clearly, this is takes the form du divided by u squared plus a squared. So integrable using the arctangent formula. Okay. So 1/3 times 1 over a, and then arctangent u divided by a plus c. Okay, and then just plug in the equivalent expressions. A is square root of 2, u is 3x. All right. And then simplify, rationalize, because we have a radical in the denominator. This is not the final answer. Okay. Next. Integral of dx divided by x, square root of 4x squared minus 9. So we have a radical again, and we have an extra variable term outside the radical. So most likely this is integrable using the Arcsecant formula. Okay, let's see. 4x squared, let's look at the radicand. We have here 4x squared minus 9. 4x squared is a perfect square na expression, di ba? It can be written as 2x, quantity of 2x squared, okay? As well as 9. 9 is a perfect square. It can be written as 3 squared, okay? So we can identify the components, no? A is 3, u is 2x, okay? Where du is what? 2dx, okay? Ayan. So in order to apply arcsecant, we have to have du in the numerator, and du should be 2dx, okay? So in order to satisfy du, we have to multiply 2 in the numerator. Since we multiplied 2, we have to divide by 2. That's why we have here 1/2 as the neutralizing factor. And then, another condition, so as to apply arcsecant, is to have an expression outside the radical that is equivalent to u, which should be 2x. And we only have x initially, diba? Kaya lang, in this case, we have an extra na factor, 1/2, for which ang 2 we can use to satisfy u outside the radical para maging 2x siya ba. So, i-redistribute natin ang 1/2 para maging 2x sa baba outside the radical, which will now satisfy the formula for arcsecant. Okay? So arcsecant, ang integral niya dapat is du divided by u square root of u squared minus a squared. Tama ba? So this is now in this form. So we can apply arcsecant. Right? Or, para mas convenient class, again, we can replace everything or express the original integral in terms of u and a. Okay? Para klaro, ang formula. So, initially we have dx sa taas, right? And dx coming from this equation, dx is what? Wait lang. Basig mag-overlap. So, dx coming from this equation, dx is du over 2 or 1/2 du. Tama ba? So, plug in natin dx is du over 2. Okay? And then, so initially we have x in the denominator outside the radical, and then from this equation, x is u over 2. So x is u over 2, plug in u over 2. Integral of what? 4x squared, where 4x squared can be written as square of 2x, tapos ang 2x is u. So this is u squared, right? Minus, initially we have 9, where 9 can be written as 3 squared, and then ang 3 is a, so that would be a squared. Okay? We have 1/2 in the numerator, we have also 1/2 in the denominator, so we can cancel 1/2. Therefore, this is now in the form du divided by u square root of u squared minus a squared. Okay? So perfectly applicable ang arcsecant. Okay? So let's now proceed with the application of the antiderivative. Right now the antiderivative. Okay? So 1 over a, right? Arcsecant of absolute value of u divided by a plus c. Okay? Where a is 3, u is 2x, so here 2x. Then a again is 3 plus c. This is now the final answer. Okay. So next, integral of dx divided by square root of e raised to 2x minus 1. Okay. We have a radical, so it's either arc sine or arcsecant. For arc sine to be applicable, dapat constant term minus variable term. Tama. Pero in this case, ang given is variable term minus constant term. Okay? So most likely arcsecant. Ang problema is that there is no variable term outside that corresponds to u. So if we, for example, if we write this as, so write this as dx divided by square root of, para ma-identify lang natin ang u and a. So e raised to 2x, it is a perfect square na expression. It can be written as e raised to x squared minus, of course, 1 is 1 squared. Okay? Therefore, u is e raised to x. And du, of course, is just e raised to x dx. Okay? And a is 1. Okay? So we have to have for arcsecant, for the arcsecant na antiderivative to work for this one, we have to have e raised to x na factor outside the radical. Okay? And also, aside from having e raised to x in the denominator outside the radical, we also have to have e raised to x in the numerator so as to satisfy du. Okay? Therefore, since kailangan ng e raised to x sa numerator, kailangan din ng e raised to x sa denominator, we can actually multiply an expression na e raised to x over e raised to x kasi essentially that's equal to 1. Di ba? Therefore, multiplying that expression essentially does not change the original identity of the given integral. Di ba? So that's why we have here e raised to x over e raised to x. Okay? Kasi nga, again, we need e raised to x in the numerator to satisfy du. And we need e raised to x in the denominator outside the radical to satisfy u. So that we can apply integral of du divided by u square root of u squared minus a squared. Okay? So in this case, we can now apply arcsecant. So 1 over a is 1. Arcsecant u over a, u is e raised to x. And then a is 1, so e raised to x lang. And then plus c. Okay? Or again, class, para mas convenient, we can replace or express the original integral in terms of u and a. Okay, so that we can clearly see what form it will follow. Okay, so let's start. Initially, we have dx, and then from our substitution, dx coming from this equation is what? Du divided by ex. I mean, e raised to x. Okay, so du divided by e raised to x. Okay, square root of e raised to x raised to 2, where e raised to x is u. Diba? So u squared minus a is 1, so a squared. And then don't forget that e raised to x is u, right? So we can replace e raised to x with u. Okay, so arcsecant. Diretso na. Okay. Next. So number 5, we have here integral of x plus 2 divided by square root of 4 minus x squared dx. Okay. So this one is not as straightforward as the previous na mga problems, no? Na direct application lang ng formula. This one will require us to manipulate first the integral. Kasi, for example, in this one, we have a radical. So this will give us an idea na maybe this is integrable using arc sine kasi nauna ang constant. I mean, constant term siya. Ang radicand ha, constant term siya minus variable term. So most likely arc sine. Kaso, we have a linear expression in the numerator. Okay? So it's not simply 1 lang so as to satisfy du. Kasi du pag tawag nito, if we apply the conditions for arc sine, where in this case a is 2 kasi 4 is 2 squared, di ba? U is what? U is x. So this will now be in the form, itong radicand is a squared minus u squared. Tama? And then du, from u equals x, du is dx. So we should only see, kumbaga, du in the numerator for this to be perfectly integrable using arc sine. Kaso in this case, obviously, it's not the case kasi we have x plus 2. Okay? So what we can try next is to attempt to apply simple na direct na u sub. Okay? Let's see if we apply direct na u sub, what will happen. So let u be equal to 4 minus x squared. Okay? du is negative 2x dx. Alright. So, in order for direct u sub to be perfectly applicable, we need to, we just need x in the numerator. Okay, and then multiply lang negative 2, divide by negative 2 para neutralize, and then proceed with power rule. Okay, if that's the case. Kaso, we have x plus 2. So, we have an additional na constant. Okay, so what we can do, class, for these types of integrals, we can break down the integral into, in this case, kasi we have two terms in the numerator, so we can break down the integral into two separate integrals. Okay, kumbaga i-distribute ang denominator to x and to 2. Okay, so something like this one. Okay, ang first term will be, this will be integrable using u sub. Okay, so na-identify na natin yung u sub, direct na u sub, coupled with power rule. Okay, ang second term, so we have a constant, we can factor out the constant, itong 2, because of the constant multiple rule. And then we will now be left with dx divided by square root of 4 minus x squared, which will take the form du divided by a squared minus u squared. Tama ba? Para arc sine naman. Okay? So, ito for the first term, ito na substitution sa second term for arc sine. Okay? So, again, first term, ayan, naka-rewrite lang ang square root of 4 minus x squared as a fractional exponent. Okay, and then, of course, it's in the denominator initially, so if we transfer this to the numerator, it becomes a negative exponent. Okay, ayan. So, again, if we apply u sub for the first term, this is what we will follow. Okay, then we have to have negative 2x dx as the du. Okay, and initially we only have x, so we can multiply negative 2 and divide negative 2 para ma-neutralize, and then proceed with power rule. Okay, or pwede explicit na u substitution, replace or express the original integral in terms of the new variable, in terms of u. Okay, so that you can directly see, or you can clearly see na it will follow u raised to n du. Okay, then second term, integrable using arc sine. Okay, so a is 2, tapos u is x, so a squared minus u squared, tapos since u is x, du is just dx, so this is now du divided by a squared minus u squared, so arc sine. Okay, and yan, simplify lang. Yeah, this is now the final answer. Okay, so again, we multiplied 2 here in the first term, in the first integral, because we want to satisfy du, so that we can apply power rule. Okay, then negative 1/2 here, result of multiplying negative 2. So we have to neutralize multiplying negative 2 by dividing negative 2. Or dividing negative 2, again, is similar to multiplying negative 1/2. Tama ba? Okay, then proceed with the integration, you'll get the final answer. Okay, next. So number 6, we have here integral of dx divided by x squared minus 4x plus 8. Okay, so we don't have a radical, it does not involve a radical, so we are left with arctangent. However, if you can still recall, I mentioned at the start of the discussion, diba, na the formulas involve incomplete quadratic expressions, diba? Kasi we can only see quadratic term, the quadratic term, and the constant term, diba? Kaso, for this particular example, it's a complete quadratic expression, no? It's a quadratic trinomial. We have the quadratic term, we have the linear term, which is supposed to be missing, so as to para apply natin ang tawag nito, inverse trigo ng mga formulas, diba? and then of course the constant term. Okay, so what we can do here, since simple polynomial expression naman nasa baba, it's not raised to a certain power other than 1, we can try to factor the expression and hope na it's a it's a perfect square trinomial na ang factor takes this form in general, x plus any constant raised to 2. Kasi if this is the case, then if we let u be equal to x plus a, so du, the resulting du is just dx, then we can just apply power rule. Tama ba? If it's not a perfect square trinomial, tapos factorable pa rin siya, pero product of two binomials, then in this case, kumbaga dead end siya, if that's the case. No? So, baka we can apply partial fraction decomposition. Okay? However, at this point, we have yet to discuss partial fraction decomposition. Pero basically, class, for this particular integrand, itong 1 divided by x squared minus 4x plus 8, if you try to decompose using the techniques in partial fraction decomposition, you'll find out na this is already the simplest form. Okay? Kasi nga, itong x squared minus 4x plus 8, if you try to factor, ito ay actually irreducible na quadratic expression. Okay? So, let's see. 8. Ano ba factors ng 8 that will result to a sum of negative 4? So, factors ng 8 can be 2 and 4. No, positive 2 and positive 4. Kaso, it will not result to a sum of negative 4. Or negative 2, negative 4, same. It will not result to negative 4 na sum. Or 1 and 8. However, it still won't result to negative 4 na sum. So, irreducible, kumbaga. Okay? So, in this case, our only option is to try to complete the square. Kasi nga, dili naman siya factorable, irreducible na siya in the context of real and rational roots. Okay? Actually, pwede siya ma-factor, pero it would involve irrational roots. Pero that's out of the scope of our discussion, kumbaga. Okay? So, we'll take it as is, itong x squared minus 4x plus 8, tapos we'll try to complete the square. Okay? And let's see what will happen. Okay? So, completing the square, how do we complete the square? We'll look at we mainly, ang primary na kumbaga na requirement is to look at the numerical coefficient of the linear term, itong negative 4. So, di ba in general, quadratic expressions can be written as a x squared plus bx plus c. So, we look at what's the value of b. Okay? And a, if for example a is not equal to 1. In this case, a is 1 lang man. So, very simple lang na completing the square. So, to complete the square, we need the expression b squared over 4a. Kasi originally, class, to complete the square, we'll look at the, again, numerical coefficient of the linear term, divide it by 2, or take its half, tapos the result, i.e. square. Okay? So, take the square of the half of the numerical coefficient of the second term, or the linear term, di ba? That is if a is equal to 1. Tama? So, maging ano siya? Sa to. Take the square of the half of the numerical coefficient of the second term. Okay? And then divide by a. Whatever the value of a is. So, ito maging b squared over 4 over a. So, kaya naging b squared over 4a. Okay? So, yan. So, identify natin ang numerical coefficients. So, walang problema sa a kasi a is 1. B is negative 4. C is 8. We basically do not need C in this case. Diba? Primary requirement is to is the coefficient ng linear term. So b squared, negative 4 squared over 4, a is 1. So that would be 16 over 4, so that's 4. Okay, so to complete the square, we need to add 4. Okay, para maging perfect square trinomial ang x squared minus 4x and yung plus 4. Okay, and since this is an expression, if we add something, if we add a number, we have to subtract the same number. So that essentially, we did not do something sa sa integral, sa expression. Okay, kumbaga unchanged, na retain kumbaga ang original identity, di ba? So plus 4 minus 4, yan. Okay, and then we group together the terms x squared minus 4x and plus 4. These three terms, when grouped together, they will form the perfect square trinomial. Tama ba? So, i-group natin, x squared minus 4x plus 4, and then the rest, 8 and negative 4, i-combine lang sila. Okay? So, 8 minus 4, that's 4. Tapos, itong x squared minus 4x plus 4, this is now a perfect square trinomial. And the factors are x minus 2 and x minus 2. So, x minus 2 squared. Okay? So, this is now in the form, if we let a be 2, u equals x minus 2. So, du is what? Dx, right? This is now in the form, dx is du, so du. X minus 2 is u, so u squared, plus a is 2, so a squared. Okay? This is now integrable using arctangent. So 1 over a is 2. That's why we have here 1/2. Arctangent u is x minus 2, over a is 2, and then plus c. Okay? So, completing the square. Okay, so remember this technique. Next, we have here dx divided by square root of 6x minus x squared. Okay, so this involves a radical. It's either arc sine or arcsecant. However, this is now a different form of the quadratic expression, no? Kasi instead of constant term and variable term na naka-square ang present, okay? Kasi that's usually the case for ano, 'di ba? That's the requirement kumbaga for inverse trigonometric functions na mga formula. In this case, we have the quadratic term and the linear term. Okay? So, missing ang constant term. So, what we can do here is try to complete the square. Okay? Kasi if we, for example, if we just apply direct na u sub, u equals 6x minus x squared, no, baka kasi pwede lang mag-power rule, no? So, let's try u equals, so this will give us 6 minus 2x dx. Okay, so in order for direct u sub and later power rule to be perfectly applicable, we need to have 6 minus 2x in the numerator, pero we don't have 6 minus 2x. Okay, so kumbaga in this case, yeah, direct u sub is not perfectly applicable. Let's try resulting to inverse trigonometric functions. But before we can apply resulting to inverse trigo functions, we need to first manipulate itong radicand, 6x minus x squared. Okay, completing the square, and we'll find out whether it's arc sine or arcsecant, depende sa form. Okay, pero in this case, it's most likely integrable using arc sine kasi we do not have a variable term outside the radical. Diba? Sige, let's see. Para mas convenient, class, we can actually isolate na lang natin ang radicand. So, radicand lang ako isulat. para mas dali. Let's isolate the radicand. We have here 6x minus x squared. Okay? So, para mas convenient ang pag-manipulate, we can actually factor out -1 so that we can rewrite this as negative x squared, quantity x squared minus 6x. Okay? Therefore, A is 1, B is -6, C of course is 0. Excuse me. Okay? And then, complete the square using this expression, b squared over 4a. So b is -6 squared over 4, a is 1. 36 divided by 4, that would be 9. Okay, so we add 9 to achieve a perfect square trinomial. Okay, so negative x squared minus 6x plus 9, and of course we have to neutralize adding 9, so we have to subtract 9. Okay, and then we group together these terms. Okay, so as to form the perfect square trinomial. Okay, so we now have negative of what? X squared minus 6x plus 9. This is x minus 3. Ano ba? X minus 3 squared. And then minus the remaining constant, minus 9. Okay, and then we can redistribute -1. No? So negative quantity of x minus 3 squared, tapos negative times -9. So that would be +9. Okay, so this is now the new form of 6x minus x squared. Okay. Ayan. Okay. So this now clearly takes the form. So if we let a be equal to 3, tapos u is x minus 3, du is what? Dx. So this now takes the form dx is du, so we have du in the numerator divided by 3 squared, where 3 is a, so a squared minus x minus 3 squared, where x minus 3 is u, so u squared. Alright, so integrable using the arc sine formula. Okay, number 8. So we have here integral of x minus 5 divided by square root of 12 plus 4x minus x squared dx. Okay. For these types of integrands, we have a quadratic expression in the radicand in the denominator. Then we have a linear expression in the numerator. We can actually check if this is just integrable by a simple u sub. No? Kasi pag mag u sub ka, u equals 12 plus 4x minus x squared. So this is a quadratic expression. If we take its differential, the result is a linear expression. We have a linear expression in the numerator. Let's see if we'll achieve x minus 5 if we take the differential of u. Okay, so, and in this case, clearly, we have here 4 minus 2x. No? So it's clear na this does not, or x minus 5, of course, not similar to 4 minus 2x. Okay, so we cannot simply apply direct na, or we can simply apply u sub directly, okay, and use power rule. So what we can do here is that we can still apply a u sub, okay, pero this will leave us with an extra term, okay, that we have to figure out later. But we can try to extract itong 4 minus 2x. We can, kumbaga, what I'm trying to say is that we can transform x minus 5 into its equivalent expression containing 4 minus 2x. And then after na transform or na convert ang x minus 5 into, again, an equivalent expression containing 4 minus 2x, we can break down the integral into separate integrals. Okay? So 1 containing itong 4 minus 2x para direct na u sub and then power rule. Okay? And then the other term na ma-generate, figure out natin later on kung ano ang applicable. Okay? Sige. So what do we do is that we isolate x minus 5. Our goal, class, is to, again, is to convert or manipulate x minus 5, convert x minus 5 into its equivalent expression that contains 4 minus 2x. Okay? So, we already have an x, pero we need negative 2x. So, first, itong negative, no? We need to achieve itong negative x muna, may na ang 2. Okay? So, to do that, we can factor out negative 1 para maging negative quantity of 5 minus x. So, okay na ang negative, kulang na lang ng negative, kulang na lang ng 2. No? Okay na negative. So, we can multiply 2 over 2. Okay? And then, just factor out 1/2. Itong 1/2. No? Di muna natin i-distribute itong 1/2. Ang i-distribute natin itong 2. Okay, so 2 times 5, that would be 10. So that we can get negative 2x. So 2 times negative x. So negative 2x. So okay na ang negative 2x. Kulang na lang is to extract 4. Okay? We have 10. Pero para mas dali, we can just add 4 and subtract 4, no, to get 4. Tapos the remaining constants i-combine lang. So negative 1/2, 10 minus 2x plus 4 minus 4, right? So we now have this expression which is equal to this expression here, you know, that will satisfy du for us to apply u sub and power rule later on. Okay? So we can just rewrite this one. Okay. So unahin natin sulat ang 4 para mas makita. So 4 minus 2x, and then we have here 10 minus 4, that would be positive 6. Okay. And then we can now distribute negative 1/2. Excuse me. 4, I mean to 4 minus 2x and 2 to 6. Okay, so we now have negative 1/2 4 minus 2x, and then negative 1/2 times 6, that would be negative 3. Okay, so this is now the equivalent form of x minus 5. Okay, for which we extracted itong 4 minus 2x. Okay, so ayan. And then we can break down this integral into two separate integrals, meaning distribute natin itong denominator to the two terms in the in the numerator. Okay, so ayan. Okay, and then first term, this is integrable using simple na u sub, direct na u sub, coupled with power rule. Okay, and then second term, check natin later if this is integrable using arc sine or arcsecant kasi merong radical na involved. Okay, tapos we'll have to check also if baka factorable ito, baka ano siya, baka perfect square trinomial, so pwede pa siya ma-simplify, so on and so forth. If dili na din, we can try integration resulting to inverse trigo. Okay, sige. So what we did here is a long and tedious na method of converting an expression into its equivalent expression, no? So as to extract this expression here para ma-satisfy ang du, no? Very ano siya, very tricky, confusing. Okay, so we have another method para mas dali siya, para mas convenient. Okay, so let me just erase lang natin. So I suggest you do this alternative na technique, alternative na way so as to convert an expression, no? Sige. So, again, initially we have x minus 5. Our goal is to convert x minus 5 into an expression, no, into its equivalent expression that contains 4 minus 2x para magamit natin for u sub. Okay? So what we can do is take x minus 5, isolate x minus 5, divide this by the expression that we need, itong 4 minus 2x. Okay? Sige, let's proceed with the division operation. So, x minus 5 divided by 4 minus 2x, we have to eliminate x first. So, in order to eliminate x, we have to multiply what? Negative 1/2. Okay? So, negative 1/2 times negative 2x, that's positive x. Okay? And then negative 1/2 divided by, negative 1/2 times 4, that's negative 2. Okay? So, x minus x cancel out. And then negative 5 minus negative 2. So that would be negative 5 plus 2, negative 3. Okay? Therefore, x minus 5 equals, kumbaga, the equivalent expression ng x minus 5 is the quotient, no, in general ganito pagkasulat class, ang quotient niya after ng division, after na divide. So quotient in this case negative 1/2 times the divisor in this case is 4 minus 2x, and then plus the remainder. Okay, so in this case minus 3. Alright, so if we simplify itong negative 1/2 times 4 minus 2x minus 3, this will give us x minus 5. Okay, so x minus 5 is equivalent to this expression. Okay, so same lang, the same as what we obtained earlier using yung long method, kumbaga. Okay, negative 1/2 times 4 minus 2x minus 3. Okay, so if you're not convinced, pwede natin siya i-simplify. So negative 1/2 distribute, that would be negative 1/2 times 4, so negative 2. And then negative 1/2 times negative 2x, so plus x, and then minus 3. Okay, so x, negative 2 plus negative 3, so that's negative 5, so plus negative 5 or minus 5. Okay, okay, so kaya bahala class, you can manipulate algebraically using the long method that we did earlier, or this one, just apply long division. Okay, so in general, the process for this long division is you isolate the expression in the numerator, okay, here, make it the dividend of the division process, of the long division process. Tapos, the divisor, so you divide this by your intended na, the expression that you need, no, based on the corresponding du from your u substitution. Okay, so divide, tapos proceed with the division, and then ang equivalent expression nitong dividend nitong x minus 5 is the quotient times the divisor. So quotient times the divisor plus the remainder. Okay, so ayan, quotient times the divisor plus the remainder. Okay, so ayan. So let's focus first on the first term. So unahin natin first term. Isolate natin ang first term, tapos later on second term, tapos i-combine natin ang antiderivatives nila. Okay, so first term muna. We have negative 1/2. We can factor out negative 1/2, diba? Constant multiple rule. And then proceed with u sub. We already did the substitution earlier, diba? So u equals 12 plus 4x minus x squared. Du is what? 4 minus 2x. Okay, dx. And we already have 4 minus 2x in the numerator. Okay, so we can proceed with power rule. Okay, pero para mas klaro class, we can rewrite itong 1 over square root of 12 plus 4x minus x squared as a exponential, as an exponential expression with a negative exponent. Okay, so yan. This now takes the form u raised to n du. So power rule, right? And then simplify lang. This is now the antiderivative of the first term. Okay. And then second term. Let's go sa second term. We have here negative 3 divided by square root of 12 plus 4x minus x squared. So we can factor out negative 3. Okay. And then, itong 12 plus 4x minus x squared, we can actually factor this one. Kaso it's not a perfect square trinomial, no? Pero we can factor using two binomials. Kaso if that's the case, if we do it that way, medyo kumbaga will run out of options. Ma-dead end siya, no? Pag i-factor lang ninyo siya using that two binomial factors kasi factorable man siya. Okay, factorable ba? 12 2 times 6. So if we, for example, isolate natin 12 plus 4x minus x squared. So if we factor out negative 1, para lang mag-positive ang leading term or ang quadratic term. Okay, so x squared minus 4x minus 12. Okay. So factors ng negative 12 that will give a sum of negative 4. That would be negative 6 and positive 2. Tama ba? So negative 6 and positive 2 multiply, that's negative 12. Tapos negative 6 plus 2, that's negative 4. Tama ba? So x minus 6, x plus 2, right? Kaso if we transform itong 12 plus 4x minus x squared using these factors, then dead end na, no? It does not follow, it does not match any formula that we have so far. Okay, pwede sana kung perfect square trinomial siya, kasi pag perfect square trinomial siya, it can be written in this form. So square root of this expression, mag-cancel out ang mag-cancel out ang inverse na operations ng square root and ng power of 2. No? So x plus a na lang. So very easy na lang ang integral. Pero in this case, dili man. So our option now is to complete the square. Okay. So again, we can base the completing the square using this expression, no, naka-factor out the negative 1. So a is 1, b is negative 4, c is negative 12. We have here b squared over 4a, right? So b is negative 4 squared, tapos 4 times 1. Alright, 16 over 4, that would be 4. Okay, so we can now write this expression as x squared minus 4x minus 12 plus 4 minus 4. Okay, and then we group together x squared, negative 4x, and positive 4. Okay, because these three terms will form a perfect square trinomial. Tama. And then the remaining constants we have here, negative 12 minus 4, which is negative 16. Okay. So ayan. if we redistribute itong -1, this will give us -12 minus 4. This is -16. Tama? So negative times -16, that would be, it will give us +16 minus quantity x squared minus 4x plus 4. Okay, so that's what happened in this line. Okay, and then x squared minus 4x plus 4, perfect square trinomial. This is equivalent to x minus 2 squared. Of course, 16 is perfect square, so 4 squared. This now takes the form what? So a is 4, u is x minus 2, du is dx, right? So du is dx. We have du in the numerator divided by square root of 4 squared, where 4 is a, so a squared, minus x minus 2 squared, where x minus 2 is u, so u squared. Therefore, this is integrable using arc sine. Okay, so -3 arc sine x minus 2 over 4 plus c. And then we combine the antiderivative of the first term and this antiderivative here of the second term. And of course, plus c. Okay, so na-overlap lang. Ayan. Okay, so this is now the final answer.